Let's now discuss how to divide by a complex number. And to do so, we must first discuss the concept of a conjugate. The conjugate of a complex number is a result of changing the sign of the imaginary number from negative to positive or positive to negative. So let's say we have our complex number, a plus bi. We have our real number and our imaginary number. The conjugate of a plus bi is a result of switching the imaginary number sign from a plus to a minus. So the real number is left alone, but the sign of the imaginary number changes. This is also true if the real number is negative. The conjugate of a complex number with a negative real number, you keep that same negative real number and you switch the sign of the imaginary number. So let's say we had 2 plus 4i. The conjugate, you want to switch the plus to a minus, giving you 2 minus 4i. If you have negative 2 plus 4i, the negative 2 remains the same, but positive 4i becomes negative 4i. Now, why is this important? Multiplying complex numbers that are conjugates will result in the removal of the imaginary number. So when we divide by a complex number, if we multiply the denominator by its conjugate, we'll be able to switch it from a complex number in the denominator to a real number. So if we had a plus bi times a minus bi, you would get a times a, which is a squared. A times negative bi would be negative abi. Bi times a would give you plus abi. And bi times negative bi would give you negative b squared I squared. The negative abi and the positive abi cancel each other out, leaving you with just a squared minus b squared I squared. I squared is equal to negative 1. So negative b squared times negative 1 gives you positive b squared. So when you multiply a complex number times its conjugate, you are able to remove the imaginary number. And if a squared is a real number and b squared is a real number, such as two integers, we'll be able to combine them to simplify the expression. So for example, 3 plus 2i times 3 minus 2i will be equal to 3 squared plus 2 squared. So by multiplying this times its conjugate, we'll get 9 plus 4, which gives us 13. And thus, we'll be able to simplify our denominators from a complex number to an integer value. For division, instead of dividing the way we do traditionally, what we are going to do is multiply the numerator and the denominator by the conjugate of the denominator. Why do we do this? A couple of things. Any number divided by itself is equal to 1. So by multiplying this fraction times 1, we are not changing the value of the fraction by adding or subtracting numbers, for example. We are simply changing the way that we represent this value. So for example, if we had 10 divided by 2, that would be equal to 5. 10 divided by 2 and 5 are just different ways of representing each other. So by multiplying the numerator and the denominator by the same number, which in essence is multiplying it times 1, the result that we have is a number that will have a simpler denominator, which will then be able to simplify into a single complex number. So you have a complex number divided by a complex number, and the result will be a complex number. Well, let me now walk you through the steps of dividing 7i by 2 plus 4i to get to 14i over 20 plus 28 over 20. So let's say you're asked to find the quotient of 7i divided by 2 plus 4i. Step 1, multiply the numerator, 7i, by the conjugate of the denominator, 2 plus 4i. The conjugate is the result of changing this plus to minus. So for step 1, 7i times 2 gives you 14i. Then you have 7i times negative 4i, which gives you negative 28i squared. And now we multiply the denominator by the conjugate. So that's 2 times 2, which equals 4. 2 times negative 4i gives us negative 8i. 4i times 2 gives us 8i, which negates the negative 8i. And 4i times negative 4i is negative 16i squared. So the next step, we want to replace each I squared with negative 1, giving us negative 28 times negative 1, which is positive 28, and negative 16 times negative 1, which is positive 16. And we can add 4 to 16 to give us 20. So after we multiply 7i divided by 2 plus 4i times 2 minus 4i over 2 minus 4i, we wind up with 14i plus 28 over 20. So we divided a complex number by a complex number. And once we break this fraction up into two separate fractions, we wind up with a complex number. 28 over 20 is our real number, plus 14i over 20 is our imaginary number. So complex divided by complex gave us a single complex number. And now we can simplify the fraction even further, this fraction here. So 28 over 20, we can divide the numerator by 4 and the denominator by 4, and that would give us 7 over 5, plus 14 can be divided by 2 and 20 can be divided by 2. So this would be 7i over 10. So the quotient of 7i divided by 2 plus 4i is equal to 7 over 5 plus 7i over 10. So that is how you go about dividing by a complex number. Let's now have you try a few practice questions. Question number 1. Find the quotient of 2 divided by 3 minus 5i. Question number 2. Find the quotient of 4 plus 3i divided by 6 minus 2i. And question number 3. Find the quotient of 7 minus 13i divided by negative 2 plus 8i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We're asked to find the quotient of 2 divided by 3 minus 5i. Step 1, multiply the numerator 2 by the conjugate of the denominator. Since the denominator is 3 minus 5i, the conjugate is the result of switching this minus to plus. So the first step, multiply the numerator by the conjugate of the denominator, 3 plus 5i, would give us 2 times 3, which is equal to 6, and 2 times positive 5i, which is equal to positive 10i. And now the second step, multiply the denominator by the conjugate of the denominator. So 3 times 3 is equal to 9. 3 times positive 5i is equal to positive 15i. Negative 5i times 3 is equal to negative 15i. This negates the positive 15i, so those are removed. And negative 5i times positive 5i is equal to negative 25i squared. So after the second step, you will want to replace this I squared with negative 1, giving you negative 25 times negative 1, which is positive 25. 9 plus 25 is 34. So we can simplify this fraction, 6 plus 10i over 34, by first breaking it up. And then we can simplify it further by dividing this numerator by 2 and this denominator by 2. So this becomes 3 over 17, plus 10 can be divided by 2, and 34 can be divided by 2 as well, giving us 5i over 17. So the final answer for 2 divided by 3 minus 5i is 3/17 plus 5i/17. Question number 2. You were asked to find the quotient of 4 plus 3i divided by 6 minus 2i. Step 1, multiply the numerator by the conjugate of the denominator. Since the denominator is 6 minus 2i, the conjugate is 6 plus 2i. So 4 times 6 is equal to 24. 4 times positive 2i is positive 8i. Positive 3i times 6 is positive 18i. 18i plus 8i gives you 26i. And 3i times 2i gives you 6i squared. The second step, multiply the denominator, 6 minus 2i, by the conjugate of the denominator, 6 plus 2i. 6 times 6 is equal to 36. 6 times positive 2i is positive 12i. Negative 2i times 6 is equal to negative 12i, which cancels out the positive 12i. And negative 2i times positive 2i is negative 4i squared. So you'll now want to replace each I squared with negative 1. So here we get 6 times negative 1, which will be equal to negative 6. And negative 4 times negative 1 will be equal to positive 4. 24 minus 6 gives you 18 in the numerator. And 36 plus 4 gives you 40 in the denominator. So we have 18 plus 26i divided by 40. So we can simplify the fraction, first by splitting it up into two separate fractions. 18 divided by 40 plus 26i divided by 40. And you can simplify this further by removing 2 from the numerator and denominator of each of these terms, leaving you with 9 over 20 plus 13i over 20. Let's take a look at question number 3. We were asked to find the quotient of 7 minus 13i divided by negative 2 plus 8i. We first want to multiply the numerator by the conjugate of the denominator. The conjugate is the result of switching this plus to minus. So we're going to multiply the numerator and denominator by negative 2 minus 8i. When we do so, we multiply 7 times negative 2, and that gives us negative 14. 7 times negative 8i gives us negative 56i. Negative 13i times negative 2 gives us positive 26i. Negative 56i plus 26i gives us negative 30i. Negative 13i times negative 8i gives us positive 104i squared. So we have our numerator after step 1. Then we multiply the denominator by the conjugate, negative 2 minus 8i as well, giving us negative 2 times negative 2, which is positive 4. Negative 2 times negative 8i gives us positive 16i. Positive 8i times negative 2 gives us negative 16i, which cancels out the positive 16i. we multiply 8i times negative 8i, giving us negative 64i squared. So now that we've multiplied the numerator and the denominator by the conjugate of the denominator, we have two different I squared terms in our expression that we want to replace with negative 1. Positive 104 times negative 1 gives you negative 104. And negative 64 times negative 1 will give you positive 64 here. Negative 14 minus 104 will give you negative 118 in the numerator. And 4 plus 64 will give you 68 in the denominator. So we wind up with negative 118 minus 30i divided by 68. And the fourth step, you want to simplify this fraction. So you first break it up into two fractions. Negative 118 divided by 68 minus 30i divided by 68. And these can be simplified further by removing 2 from each term. We have all even numbers. Negative 118 divided by 68 becomes negative 59 over 34 minus 15i over 34.